everybody, in this video I'm going to be sharing with you some trigonometric identities. Now these identities will be really useful in math competitions, and also before you actually start watching this video and continue watching it, I advise that you go to watch my last video, which is about the basics of trigonometry. However, if you already know what sine, cosine, and tangent are, you can continue with this video. Now the first trigonometric identities that I'm going to go over, and they're pretty well known and used a lot, are the cosine, sine, and tangent sum formulas, and I'll show you what they are in a moment. Okay, so here are the three sum identities for each of cosine, sine, and tangent. Now, if you want me to make a proof of this, which I'm not going to do in this video, be sure to put a comment down below so I know that I will have to make proofs for the addition identities. And if you want any more information about the other identities, I'll also try to make a separate video for proofs for those too. Now right here I also have some pretty important identities, as these are useful whenever you want to find the differences of two angles. So let's say you wanted to find cosine of A minus B instead of A plus B. Now, since you know that cos of negative A is just cos of A, you can just plug that in and find what the formula for difference identities are. And I'll let you figure that out for yourself. Now, I didn't include the tangent because this one is really easy to just prove. So we have tangent of negative A is equal to the sine of negative A over the cosine of negative A. And we already know those values from the identities that we have right in front of us. So this becomes negative sine of A over cosine of A, and that just becomes negative tangent of A. So we have three functions, and we now know what the negative of each is. Now, you may be wondering, doesn't this mean that each of the function sine is an odd function, the function cosine is an even function, and the function tangent is an odd function? And yes, that is indeed. Each of these functions is either an odd or an even function, and you can graph it to prove it too. Now, if you don't know what odd or even is, you don't have to worry. You'll learn that later on in pre-calculus. Next up, we have the double angle identities, which we take the angle and multiply it by 2. This is also extremely useful when you want to shortcut through things instead of going through with the angle addition way. We can see that sine of 2a is equal to sine of a plus a. And you could go that way, but we have a simpler solution. And this is found by plugging in a and a into the sine addition identity, which we have earlier. And so sine of 2a ends up being 2 times sine of a times cosine of a. And we can do the same thing with cosine, which becomes actually a number of different values. It can be cosine of a squared minus sine of a squared. And there are other ways to represent each of these identities. Now for tangent of 2a, I'm also going to let you figure that out, or you can search that up yourself. Now, like I said, there are different ways to write these identities, and this is because of the one of the most important trigonometric identities, which is cosine of a squared plus sine of a squared is equal to 1. And that's proved with the unit circle. And basically that's just Pythagorean theorem. We have the unit circle, we have a triangle, the height is sine of theta, and the length is cosine of theta. So therefore, by using a Pythagorean theorem, we have that the sine squared plus cosine squared of each theta is equal to 1. Now, when we solve for one of them, we end up getting a certain value. For example, cosine of A is actually equal to the square root of 1 minus sine of A squared. And when we plug that into the cosine of two-way identity, we actually get 1 minus sine A squared minus sine A squared, and that actually becomes 1 minus 2 sine of A squared. And we can also do the same with sine by solving for sine in this equation and then plugging into any one of the equations. So as you can see, we can write each of these identities in different ways depending on what situation we're in. For example, if we're only given sine of A, then we would use this identity. Now there are also sine of A over 2 identities and cosine of A over 2 and tangent of A over 2 identities, but I'm not going to go over those because they're also pretty easy to derive and you can find them on the internet. There's a lot of identities that you can find on the internet. For example, sine of 3A, which isn't that useful. However, it is pretty useful in certain situations. Okay, so this is the last identity that I'm going to be going over, and this is the product to sum identity. This identity I find is used a lot in problems where they don't actually show you some sort of geometric diagram and it's more of the equations. However, I still find this identity to be pretty useful because I've seen it in a multitude of college level competitions. Alright, so those are the few trigonometric identities that I went over. I hope you enjoyed this video. Be sure to like and subscribe. Thanks for watching.